Okay, so the random bonus material that I thought would be useful to mention, but it will not be on the exam or anything, is that when we've talked about tabular data in this course, we've always talked about a single table. And what if your data set has multiple tables, like for example, multiple CSV files like this Formula One racing data set? And for those of you who've taken database courses like CPSC 304 or 404 or something, this will click, I think, but I'll try. This should make sense even if you haven't. Should also plug, we're also hoping to make a databases for data science course in the future as well. Okay, so here's some stuff about some race car stuff. So you got your race ID, your driver, all kinds of stuff. How many laps, time, whatever, fastest lap. And so let's say we want to predict milliseconds, which is how long did it take them to complete the race, basically. And we want to predict that based on this. Well, we wouldn't really, a lot of this is again stuff we wouldn't have in deployment. Like we wouldn't know stuff about how long they took if we're trying to predict how long they took. We wouldn't know their fastest lap if we're trying to predict how long they took. We wouldn't know they were in second place before the race started. So we actually basically have to drop most of these columns. And so I'm just going to drop everything except who the racer is and who the driver is. And I'm going to drop these nan rows if the target value is missing. So we have this. This is basically our data set. We have race, in race number 18, driver 1 took this long. In race number 18, driver number 2 took that long. And so we have 6,000 rows and 3 columns. And so kind of the baseline thing to do would be to just use this to make our prediction. And all we're going to be able to learn about is how fast is each driver and how fast is each race. Although, well, yeah, okay. So I'm going to train test split. I'll do a dummy regressor. And I'm going to one-hot encode the race ID and the driver ID. And then I'm going to do a ridge. And I was actually pretty surprised that this got such a good score. And kind of, I didn't have time to find a new data set and redo everything. And so, but I was expecting it to be a lot worse with only that amount of information. But it's all good. I can still get my point across. Yeah, something I'm a little confused about that. But maybe it's just like, maybe those are the main factors, which race is it and which driver is it. But, you know, here's another, and here, maybe I can be more convincing to you then. How about I try to convince you like this? But what if we want to predict for a new racetrack or a new driver? So here's a better motivation, because the score is already good, so I can't convince you the score is horrible. But we can't transfer this to a new driver because we've only learned about driver IDs in the training set. We can't transfer this to a new racetrack. But if we had features about the driver, which I'm going to get you in a second, or features about the race ID, we could actually use this model on a brand new driver who's never raced in the data set, but we know some things about them. So that's a better motivation. Okay, so this data set actually has other tables in it. It has the drivers table. And so for each driver ID corresponding to the other table, so in the other table, driver ID number 1, we actually know stuff about them. We know their name and their date of birth and their nationality and their Wikipedia URL. And so maybe some of this could be useful because, for example, maybe we're going to use their age as a feature. Maybe we'll find youngsters are driving faster or who knows. And so can we combine the different tables is basically what I'm trying to talk about here. So can we use the driver's nationality and age as a features? And pandas merge is basically the function that's going to do that for us. And what pandas merge does is it takes 2 different data frames and it says merge them together, but they need to have a commonality in them. In this case, it's driver ID. So it says, hey, the original table is going to have a driver ID column. This new table is going to have a driver ID column. Merge them. So every time you see driver ID 1, in the original table, plunk in all this information about driver ID 1, and this is what you get. And so again, for people who've taken databases, you're thinking here primary key, foreign key, all that kind of stuff. But we don't really need that terminology for this to make sense, I think. So here's what you can see. For driver 1, you now have all that information about driver 1. So all this stuff is duplicated, you can see, because this is all driver 1, and that's completely fine. And this is all the information about driver 840, and this is 840 again, so we duplicate it again, and this is 838, and so on. And so now we still have the target in here, so now we can maybe try to learn something about correlating nationality or age versus speediness, and then we might be able to apply this to a new driver or a new racer. Questions or comments? Oh, are the two tabular data that you're going to concatenate having the same number of rows? No, they actually don't have the same number of rows. So the original one has 6,003 rows, and the driver ID has 842 rows because there's only 842 unique drivers, because the driver ID is actually replicated in this original table. And so they don't have the same number of rows, and that's okay here, because we just, for every row, we're going to take the driver ID, look up that driver ID in another table, and plunk in all the features. Good question. Okay, so the keyword on told it which column to use. Yeah, okay, all good. Any other questions? Okay, so now I can drop some other columns, like I'm not going to use their Wikipedia link for prediction, for example. Although, I mean, how cool is that? Like, you could take their Wikipedia link, use a web crawler, get some text features from their Wikipedia article. There's a lot of fun stuff we can do with feature engineering. Okay, the common column could be time. I don't know exactly what that is referring to. So maybe you could elaborate, and I'll keep going in the meantime. So now we have this date of birth thing, and now going back to the time series lecture, it's all coming together. The time series lecture, we talked about parsing dates. So you can parse the dates here, and you can take now minus their date of birth, which tells you how long they've been alive from when they were born to now. And then you can take that into seconds and then convert seconds to years. And then you can actually take their date of birth and make a new column that is their age in years. How awesome is that? Because pandas knew this was a date, and we can do all kinds of fun feature engineering. So now for every date of birth, we've converted that into an age, which is an actual numeric feature we could pass into a regression model, whereas date of birth, if we just pass in date of birth into ridge, it's going to throw an error. But if we pass in numeric features, well, we're used to numeric features. So yeah, here's, wow, these people are pretty young. Okay, I'm just going to look in the chat. You used ID as a common column. Yes, I used ID, which is very typical. An ID is often like some sort of unique identifier, like you can imagine for a student. You got their grades in the course and use their student number to look it up, and somewhere else you have some other things about the student, etc., etc. Pandas OP, I love it. Yeah, pandas is awesome. Likewise, we can get information about the races. So yeah, there's actually another table here in this data set, which is the races table. And so here, for each race ID, we have stuff about that. When it was, what it's called, I don't know, some other stuff about it. So maybe here, I actually have no clue what round and circuit ID are referring to here, but maybe we could get some useful features out of this. Like maybe circuit ID is actually like where it is. And so like if I have a race last year in a certain racetrack and a race this year in a certain racetrack, those would have different race IDs because they're different races, but the same circuit ID or something like that. And if that was true, this would be an excellent column to include in our feature engineering, because which racetrack it is definitely going to be useful to predicting how long it took. So that's cool. So we can do another merge. We can merge the one we already had with this one, and this time the common column is race ID. And so now I have it all in one place. I have milliseconds, I have some features about the person that I grabbed from one table, like their age and their nationality. I have some features about the race that I grabbed. And now, if I was actually going to use this to predict for a new driver or a new race, then I would probably want to drop race ID and driver ID, because I don't want to learn about a particular driver. I want to make a model that learns about driver age and driver nationality. So if I have a new driver that I've never seen before, it's a new ID. I can't use what I've learned about that ID because I've never seen that driver ID before, but I can look up what I know about their nationality, because I'll have coefficients for the different nationalities and coefficients for the different ages. And likewise, if I go to a new race, it might be race 509 happening tomorrow, and I don't have any data on race 509, but I have the circuit ID of that race is 1, and I have past races with that circuit ID, and so I can use my model, etc. So maybe I'll try dropping these. Okay, so we have this final thing. Yeah, let me drop race ID. Okay, so now I have this data set where milliseconds is the target, and this column is the nationality of the driver, the age of the driver, the year of the race, I don't know what round is, and the circuit, which is probably the racetrack of the race. And now I can do my whole usual thing that we do. I can have a column transformer, I can one-hot encode some things like the nationality, I can scale some things like the driver age, and I can train my whole model. And let me, yeah, so the score was actually bad, which was annoying, but that's really not the point here. Let me, great. Okay, so if I fit this model now, then I can actually use this model on new cases, even if I've never seen that driver before and their driver ID. So I don't know if this will actually work. We can try it. Yeah, so here I can see I have some coefficients. The scales are all really big because everything's in milliseconds. And maybe that looks a little bit questionable to me. I feel like there's something a bit weird going on here, but I could now use this on a new person and make a prediction is really what I'm trying to say. So that's it. I'm out of time, and long story short, if you have different tables, it can be useful to combine them when doing your feature engineering. That's basically what I wanted to show. Any questions? Okay, let's wrap it up here, and I'll see you on Tuesday for Sina's guest lecture.